Hello and welcome to your video notes for Algebra 1. These are going to be your 4.10 video notes, and this video is going to be mainly on vocabulary. So I want you to pay attention to the words that you're going to write down in your notes, listen to how I say these words, and be ready to practice saying and using these words in class every day for this entire unit and next year. So go ahead and title your notes Algebra 1 Video Notes 4.10. We are going to talk about key features of quadratic graphs. And what are quadratic graphs? Well, I want to show you on your screen that you have a picture of a parabola with a soccer ball. So when you kick a soccer ball or shoot an arrow, fire a missile, or throw a stone, or throw your little brother off of a cliff, it arcs up into the air and it comes back down. What happens is it follows the path of a parabola. We're going to talk about what a parabola is, and define it in our words now. You will formally define a parabola later in your math career. Here's a picture. In this video, I really recommend that you use the pause button a lot so that you can write down the vocabulary on the screen, and then you can listen to me explain a little bit more about the vocabulary. So here's a picture. It's of a parabola, and then I actually don't have to write that much today. But we have a parabola. It's in blue, so I'll match. And this parabola is facing upwards. It has this orange axis of symmetry, which we're going to define some x-intercepts or solutions, y-intercept, which you've heard of before, and a vertex. So let's talk about the first two vocabulary words. You can pause the video here to write it down. And now I can talk about it. So a quadratic in standard form, you've seen this before, but I want to highlight it again, that it's going to be in the form of ax squared plus bx plus c. A cannot equal to 0. If a is equal to 0, and this whole term is equal to 0, then you just get a line, which is not a parabola. Lines are not the same as parabolas. Okay, so this is in standard form. You had a different version of standard form for lines, and this is the standard form for quadratics. Parabola, I mentioned this earlier, but it's the picture of a quadratic, or the graph. Every single equation in standard form, every single quadratic that has an equal sign and letters and numbers associated with it also has a picture that goes along with it, and that picture is a graph. Okay. Next vocabulary words, the next three are minimum, maximum, and vertex. You can go ahead and pause the video so you can write down these three things. And now I'll talk about the minimum. Minimum is the lowest point on the graph. So if you have a graph that is going upwards, we're going to talk about a special word that means that it's going upwards. The lowest point is down here. The other way to do this is parabolas can also face downwards, and that means they have a maximum point as well. So a maximum is the highest point on the graph. Some graphs, like this blue one, it doesn't have a maximum because it goes on forever. That's what these arrows are for. And then this green graph doesn't have a minimum. It goes on forever as well. Now, these points are very special points, and they even have a name. It's called a vertex. So a vertex is the maximum or minimum of a graph. It's written in the coordinate form x, y. When I ask you to identify the vertex, in order to do that, you have to be able to give me a coordinate, an x, y coordinate. For example, this vertex down here is 1, 2, 3, -4. So you can write vertex is, pause at 1, -4. I need an x, y value to give me the point of the vertex. Okay, now let's talk about solutions. So solutions are also known as roots, zeros, or x-intercepts. And I usually use these two the most, zeros and roots, but they're also x-intercepts as well. Let's see if I can bring this down. Okay. I use the word roots and zeros a lot, and I use them interchangeably, which means I mean the same thing. I actually mean solutions, but I use the words zeros and roots. So you're going to hear me say, find the roots or find the zeros. And what I mean is find the solutions. And the solutions are the points where the graph touches the x-axis. So you see this is the x-axis here, x. And this graph touches the x-axis at 2 points. Sometimes it only touches at 1 point. Let me give you an example. So one solution. This is 2 solutions up here. You can sketch in this graph in your notes. And this is 0 solutions. Let me show you a picture. Okay. So if there's 1 solution, maybe it looks like this. It touches the graph exactly once. That is possible. It is possible that a quadratic equation has only 1 solution. It is also possible that a quadratic equation doesn't have any solutions. Because look, it doesn't touch the x-axis at all. It touches it 0 times. And then most commonly, the graph touches the x-axis twice. And that's right here and here. Okay, concavity. I love this word. Concavity. It describes the shape of a negative versus positive parabola. And when I talk about concavity, it's either concave up. Oh, I didn't even write this. Okay, so this is, oh boy, where am I going? Concave up. You can describe a parabola as concave up, or you can describe it as concave down. Those are the only 2 ways you can describe concavity of a parabola. So when it's concave up, I usually do this symbol where it's kind of like I just show you on my hand. And then if it's concave down, I'll go like this. I don't know if you can see that, but I'll do concave down. And so you can tell me concave up or concave down. And it's just one way to describe the parabola, which leads us into the last couple of last few words. So we have increasing and decreasing when describing parabolas, and then we have one more word. So increasing. The y value of the graph gets bigger as you read from left to right. So I want to draw you a picture, and this is going to work for both words, increasing and decreasing. You might have heard the words increasing and decreasing before in other parts of your life, but I want to talk about what it means when we're talking about parabolas. So say I have a parabola. Between on the left side here, where I'm going to highlight in orange, the graph is decreasing. Because if I'm reading from left to right, the graph is going down. So it's decreasing. What I'm going to highlight here in pink is where the graph is increasing. So that's from here to here. And there are different ways you can describe when the graph is increasing or decreasing. You're going to cover that more later in your math career, but I just want to show you now that this graph is increasing on the right because when I read from left to right, the graph gets bigger, and it's decreasing on the left side because when I read from left to right, the graph gets smaller. There is a point where it changes from decreasing to increasing. And then you can draw a picture. Well, you can also draw a picture of when it changes. It increases first and then decreases. So for example, it increases all the way to here, and then it decreases. So parabolas will all both increase and decrease. Okay, last word, we're going to talk about this word a lot. We're going to write equations for it, and it's going to be really important for our study with parabolas. It is the axis of symmetry. This axis of symmetry is the vertical line that goes directly down the middle of the parabola. You might have heard this word before if you've talked about geometry and you've talked about symmetry. Let's see if I can bring this Oh no, I don't want that. I'm gonna, hold on, let me see if I can put the picture there. Okay, so I have the picture of the graph. The vertical line, this orange line that goes directly down the middle of the parabola, it only touches the vertex. A lot of things have axis of symmetries. If you put your hands together, you can probably imagine an axis of symmetry because it mirrors both sides. So we're going to look at that axis of symmetry. It tells us a lot of information about a graph. And so when I ask you what is the axis of symmetry, the way you write it, if I ask you, what is the axis of symmetry? What is the graph's axis of symmetry? You would say your answer would be x is equal to some number. X is equal to. This is how you write that line. In this case, x is going to equal to 1 because this starts at 0 and then it goes to 1. So your axis of symmetry is at every x is equal to 1 value. When you're going to practice this. So right now, you're going to write your summary. Your summary may be using the vocabulary words in a sentence. Your summary may be that quadratics, you may choose one of the vocabulary words to talk about in your summary. But either way, you're going to need your summary in class tomorrow and go through, and you can pause the video now if you missed any of the words. Bye. Thanks.